Hey everybody, welcome back to another fun and exciting Algebra 1 class. Today's lesson will be in 5.4 and we're going to be talking about different types of lines on the graph and different types of systems. So 166 is the page number, page 166, types of systems. So now we've kind of talked about how to solve a system. We've looked at three different methods: graphing, substituting, and then elimination. And so maybe you found one that you kind of like a little bit better. You've kind of found the limitations of graphing. You found where substitution works really well, especially if there's a variable that's already isolated. You have x equals something or y equals something. And then elimination, maybe you figured that out and you're like, okay, I like this method. So hopefully you're starting to kind of get to the point where you're getting a little bit of a grasp on those three. And now what we're going to talk about is what we call the types of systems. There's really three different types of systems, and they're found here on page 166. So let's go ahead and look down at these types of systems in table A, and then we'll go back up and read some of those things that are up in the paragraph. So the first one is when you have intersecting lines. So these lines are just crossing. These are the ones that we've been working on where the lines cross each other. I have told you about the other ones, but I haven't really put it in specific terms like this lesson does. So the first one is intersecting lines. Those are the ones that they have one solution, they meet one time, they intersect, they cross each other. Okay. The second type is what's called coinciding lines. Coinciding. And so what does it mean when they coincide? It means that they're on top of each other. Okay. So every single point is the exact same because the two lines are coming in directly on top of each other. Every single point on the entire line touches every single point on the other line. Okay. And then the third type, and we've already talked about this one, is the parallel lines. The fact that they never touch each other. They just go one, straight in one direction, and they never touch each other. No matter how far you extend the lines, they never touch each other. Okay? That is a parallel line. So these are three types of systems of equations. Each one of them has a different way of kind of solving it or figuring out what it is. The first one with intersecting lines, you are going to get one solution. That's really important to remember. One solution. On the coincident lines or the coinciding lines, you are going to get indefinite solutions. You get every solution. On this one, it looks like when you get like 6 equals 6. Okay, and we've done those. I've introduced these before, so hopefully you're tracking with me. And then with the parallel lines, there is no solution. You get something like 7 equals 2. Okay, 7 does not equal 2. And so that would not be a solution. And so those lines would be parallel. All right, let's look over here real quick and let me kind of go back over those just one by one. So the first one is the one solution, the intersecting lines. And what I want to do here is I want to just kind of show you what this is going to look like once you solve it out. So whether obviously if you're using graphing, this one is just going to cross at some point, okay? If you're using the elimination or the substitution methods, when you get this one, you're going to get something that looks like, maybe you'll get like a y equals 3x plus 2, something like that, okay? If you get that, that is going to give you one solution. You could also get something like x equals 3. Okay, that would be one solution. If x equals 3, one solution, that's actually a line that's a straight line at the number 3. So you count over to the number 3, you put a mark, and then that's a line at the number 3. So these are all different ways of solving them if you get one solution. Now, with the next one, with identity, These are coincident lines, or these are coinciding lines. So what happens with these is these lines are right on top of each other. So you have, let me just kind of draw it like this, and I know it's not going to be perfect, but this way you can actually see it, and that line's going to be on top of the other line. So the green line is on top of the pink line, okay? So that's one way to do a identity. So if you're graphing and you get the two lines that are right on top of each other, okay, that is an identity. And then the other way would be if you get something like when you solve it out using your system of equations. So when you solve it using substitution or elimination, you get something like 7 equals 7. If you get that, or if you get y plus 3 equals y plus 3, if you get something like that, you now have an identity, and you have what we call coincident lines or coinciding lines. Or the other way, I'm going to show you this real quick. I told you I was going to look back in that text, and I'm going to show you what these words mean in just a second, but I kind of wanted to go through these three first, and then we'll go back and show you what these words at the end mean. All right, so the last way that we can kind of look at these is by a contradiction. And these types of lines, these never cross each other. These are parallel. Actually, those ones would cross each other. We'll do that a little bit better. And so these ones are parallel lines. They never cross each other. Now, when you get a solution for these look something like 7 equals 3. Okay, so if that's not true, then you have a contradiction. A contradiction means they don't add up. They don't make sense together. All right, so they contradict each other. They say something different. And so if you get 7 equals 3, then you have a contradiction. All right, so I told you I was going to look at these words. So consistent, dependent, inconsistent, independent. What are these words? All right, so jumping back over here to the book on page 166, we're going to see this is in boldface here, consistent system. So what is that? A system that graphs as intersecting lines or as coinciding lines. So you could either have them crossing or touching each other, because it has at least one solution. What does that mean? Well, it has either one crossing spot, that's one solution, or it has indefinite, the lines touch each other, and it has all of the solutions in common. So then the other one would be inconsistent. So jumping back over here, we have consistent in the one solution problems, the ones that cross once. And then we have consistent again in the identity ones, the ones that are coinciding, the ones that are touching each other at every point. Okay. Inconsistent would be if they contradict each other or if they are parallel. Okay. You don't really have to know all these terms like really well, but I want to go over them just so that you kind of have them, and you make sure that if you see them, you're not confused by them. All right, one more set of terms here is dependent equations and independent equations. All right, so the dependent ones graph as coinciding lines because they can be simplified such that they match exactly. By contrast, independent equations are unrelated equations that graph as completely different line, either intersecting or parallel. So this is kind of different. Like with the consistent and inconsistent, they kind of match differently. Now these independent, dependent, they look different. So coming back over here, the independent ones on this one are going to be the one solution and the no solution, okay, because those are independent lines. This is a dependent line because it depends on the other line. They're touching each other, so they're dependent on each other. So again, just so you know those, I wanted to make sure that we kind of went through those real quick. All right, so here on example 5.4, you'll see, and we can just look through this. When we solve this, okay, we're going to solve this algebraically, you could graph those, and if they touch each other once, then it's a one solution. It's an intersecting line, right? If they touch each other everywhere, then they're identity. If they don't touch each other, they're parallel, or what we call contradiction, right? But what if we can't solve them using a graph? What if we actually use our substitution or our elimination? So on this first one, you'll see that we went through this y is already solved for, so it doesn't have a coefficient in front of it. So in this first one, they solve it to get y equals negative 3 over 2x plus 2. Then they substitute. So they've solved this one with substitution. They substitute this back in, and then they work this out, and they find out that 4 equals negative 3. Well, what happens when you get 4 equals negative 3? Well, if you go back and look at the notes that we've written, when 4 equals negative 3, that's a contradiction. So we have no solution. In other words, those are going to be parallel lines. Those are never going to touch each other. They have no solution. It's contradiction, parallel lines. On this next one, they solve this one with elimination. So if you look here, they found in this one, they needed to multiply this by negative 2. And when they did that, they took this to negative 6x, and then they multiplied this one by positive 2, and this took this to positive 6x. So here's your new equations down here. So the first one, multiplied by negative 2, and that gives you negative 6x minus 14y equals 10. And then when they multiplied this one by 2 to get this one to eliminate, they get 6x plus 14y equals negative 10. Well, look what happens. This cancels, the 14y's cancel, and the 10's cancel. Everything cancels, and you end up with 0 equals 0. Well, what happens when you get something that something equals something else? If we look back over here, we find that that's identity. When 7 equals 7, when 0 equals 0, then we have an identity. So we would label that one as an identity, as a coincident line, coinciding line, consistent, and dependent. So use all of these things right here. These tell us all about this one right here with this negative, with this 0 equals 0. All right, so several different things going on there, but for the most part, we're just taking what we've learned in the last lessons, and we're now identifying what each one of those is called. So they each have their own name. If you get just one solution, you have intersecting lines. That's a consistent, independent system of equations. If you get 7 equals 7, if you get the lines are on top of each other, that's identity, that's coinciding lines, that's a consistent, dependent system of equations. And then if you get something like 7 equals 3, you end up with contradiction, you have parallel lines, and you have an inconsistent, independent system of equations. Okay? So again, just defining what we've been doing in the last couple lessons and what we've been looking at. So that's all I got for you. Hope you learned something there. If you missed anything, slide it back, watch it again. We'll see you later. Have a good one. Bye-bye.